Even if we don't all love it as much as I do, I'm sure we all know about the sport of basketball. However, most people just see it as a game. In today's video, I'll be going over a few of the physics concepts that are involved in this beautiful game. Let's start with some observations that we can make about a basketball and see how we can infer or interpret their relevance. Firstly, the basketball is round and spherical. This can be inferred as to allow easy manipulation of the ball, allowing it to roll and move in different directions. Imagine playing basketball with a cubic ball. Secondly, the basketball is made of durable materials such as rubber or good leather. This makes the ball degrade slower and allows it to be used for much longer compared to using materials that are less suitable or less durable. Finally, the basketball has a textured surface. It isn't smooth. This grip-inducing idea allows players to maintain a much better control over the ball, whether they're dribbling, shooting, or even passing. Now let's get into some real physics. Here's a clip that I'll be using as the base of my experiment. For reference, I'm the one in the white shirt and the one who scores. The place that I shoot from is where we're going to be using for our experiment. Apart from some cool fakes and fun celebrations, two important physics concepts that we can clearly see are dynamics and kinematics. The goal of my experiment is to determine and analyze the final angle through which the ball enters the rim from a shot both with a jump and without a jump. To accurately perform this experiment, I'm assuming that my shooting form or technique is kept the same, and the place at which I'm shooting the ball from is the exact same as well. I used the help of my younger brother Parkle and my good friend Cherith to acquire the measurements that I needed to conduct this experiment. So the question I'm answering, or the relation that I'm finding, is how does jumping versus not jumping in your shot affect the angle at which the ball enters the rim in a made basket? My hypothesis or prediction was that with a jump, my arc would be greater, which should therefore increase the angle of entry for the ball when I do jump. Apart from already measuring my height, we found that I shoot the ball from exactly the top of my head, meaning the ball's trajectory starts wherever my head is. We found the horizontal distance of how far I was from the net when I shot, how high I jumped during my shot, as well as the height of the net that we normally play on. I found the time by finding the time of which the ball just leaves my hand, as well as the time that the ball just enters the rim, and took that time in between. Now let's take a look at what happened with both of my calculations. So you may notice the real difference between both calculations is just the vertical displacement. For the one without a jump, we disregard how high I jump. This changes the vertical displacement that the ball has to travel in order to successfully make it through the hoop. I used how far I was from the net horizontally, as well as time, to find the horizontal velocity of the ball. So this remains constant throughout the system, which means that the initial Vx and the final Vx are both the same. To find the velocity final for our y component, I used one of the 5 kinematic equations. Then using Vx and Vy final, I determined the angle at which the ball entered the rim. Even though it's only 3 degrees greater when I do jump, those 3 degrees play a significant factor in whether the ball goes in or if it hits the rim and bounces out. Through analyzing my data, I can draw the conclusion that my hypothesis was right. The angle of the ball entering the rim is greater when I do jump. Jumping during my shot allows me to create a greater arc while keeping everything else in my shooting form constant. Since the angle of entry of the ball is greater, the chances of my shot going in are increased as well. So the higher I jump, the more desirable my arc. This is why NBA players perfect their jumping, not just for dunking, but very clearly for shooting as well. Now, if I were to improve the infamous basketball, I would definitely focus on using a new prototype that's currently in development. Using a new technology called additive manufacturing, Wilson, the ball manufacturing company, has started developing a new airless basketball that plays, fields, and bounces just like a regular basketball. But what are the benefits? Well, since this ball is basically 3D printed in one piece and not assembled like normal basketballs, we can get the perfect ball every single time. There are also no leftover materials that need to be thrown away after production. From a consumer standpoint, the ball will never go flat and it'll never pop because it has no air. Also, having a ball with no air pressure means that it's going to play and feel the exact same no matter the climate, geographical location, or any other variable. I hope you guys enjoyed talking about physics and basketball as much as I did in this video, and I hope you guys enjoyed my experiment as well. As always, I'll see you guys next time.